Today we'll be talking about the LeetCode daily problem, maximum subsequence score. So you could pause the video and read this, but I want to go straight away into the discussion of the problem. So my first instinct could be the same as yours, is that when you first see subsequence, it gives you like a pretty, your head should go into dynamic programming. If you've looked at the previous few videos, they all have to do with subsequences. However, there is one big constraint or that actually works in our favor, because we know that the subsequences have to be of length k. So this constraint actually works in our favor because we know our subsequence length. And so if now that you have this information, your head might go to another place. Anytime we think of like optimizing the largest k or getting the smallest k, we think of using a heap. Okay, so now that we have that in mind, how do we actually solve this? Well, let's think about it this way. The actual formula has a way to go ahead and kind of give us like a hint on what to do. If we have the minimum, right, no matter what we pick for our subsequence here, the minimum is only going to matter. So that kind of tells us that, we can kind of greedily pick from nums1, given that we have a minimum. Now, what do I mean by this? Okay, so let me use this example 2. Let's say we choose our minimum to be 5, right? And let's say, well, k equals 1 is actually kind of trivial in this case. Let's say that it was k equals 2. So if we pick our minimum to be 5 in nums2, which corresponds to 2 here, it doesn't matter what these other values are, because they're all smaller than 5. So we essentially have the freedom to choose any one of these numbers, and it wouldn't affect like the second part, the multiplication part, because the smallest is just 5 regardless. So it doesn't matter that we choose something that's 7, for example, instead of 10, because all that matters is here, because again, the 5 is the minimum. Okay, now that we have this basic idea in mind, how do we go forward into actually solving this? Well, a greedy approach, again, or somewhat greedy approach, works for here. So if we think about it this way, like I said before in the example, 5 is going to be, like, it gives us freedom of choice with the other numbers greater than 5. So how do we know what numbers are going to be, or where's going to be greater than 5? Well, let's think about sorting, right? So if we sort this in reverse order, then anything that's greater than 5 will be to the left of it. So all we have to do is to sort in reverse order and sort of iterate until we have the until we get to, let's say, 5. But in this case, we'll go through the entire array, 6, 7, 9, and then anything before that is fair game. Like anything before that in the index wise and nums1 is fair game to choose. And we'll always just pick the top k numbers of the index on and before. Actually, it's on and before. Okay, so let's put this into implementation. Let's do some visualization first. So let's draw it out. So suppose n2 is sorted in decreasing order. So that would be 10, 9, 7, 6, 5. And then corresponding to that is so 10 has 3, 7 is 4. Oops, should have done 9 first. 9 is 1, 6 is also 1, and 5 is 2. Okay. So as I mentioned before, let's say k equals 2, right? And so we'll build our heap starting from 2. because it has to be like of length k. So we'll first build our k with these two. Okay, now we move on to 7, right? 7, out of 4 and 3, which one, or 4, 1, and 3, which one's the largest? Well, from 1 and 3, we can tell that 4 is bigger than 1. So let's choose 4 and 3. And so our answer would be 7 times 4 plus, or 3 plus 4 times 7. Okay, and then now moving on to 6, right? So again, we see that anything before 6 is fair game. Like anything in this range we can pick, since our minimum is going to be 6. And then same with 5. And then also we update our k largest as we go. Okay, finally, let's put this into code. So for our code, like we discussed earlier, let's start by creating the reversed array. We'll call it reversed, and we'll put n2, n1, so that we call sort. It sorts by n2 for n1 to n. So, all right, and let's sort it, of course, in reverse order. And then let's build the heap from here. So we'll call it H for the heap. And this is going to be, of course, N1, right, for in reverse, and we'll pick the first K for now. Okay. Now that we've had that, we have to actually heapify it. Can't forget that. Then we can basically calculate the answer. And so to calculate the answer, you first have to find the total, right? And the total, what I mean by total is these numbers added up. So the total would just be the sum of the heap, some of the elements in the heap. And so now that we have the total, our initial answer is going to be this total times the smallest in the subsequence, which remember our subsequence when we first built it, like the smallest is just going to be at k because it's in reverse order. So let's do that. It's going to be k minus 1 because it's 0 indexed, and of course 0 represents n2, which is what we're multiplying. Okay. And let's actually put some space in between here to make it easier to look at. So now we can go ahead and go through the array, or the rest of the array. So again, this is n2, n1 in, what's not, I call it reverse. The k plus 1th number forward. First of all, we check to see if this new n1 is bigger than anything, or bigger than the k we've seen so far. In other words, if n1 is larger than what we have in the total, or sorry, not total, in the min heap, then we sort of replace it. So remember, we have to subtract it from the total. Sorry. And let's pop it also on the way. We have to add the new one to the total. And then, of course, we also have to push it in the heap. So the only time our answer would change if this is true. So we really only need to compare answers if this is true, because anything that you'll do later on won't change heap, and we're only getting smaller n's or n2s. And so we'll only do this. I mean, you could also just take it outside of this if condition just to check everything, but it's very slightly more efficient if we do it this way. And so answer, or our current calculation, which would be n2 times the total. Okay, so in the end, our answer will be returned. Okay, so let's double check. And we see that it passes. Thanks for watching, and I'll see you in the next one.